Revolutionary English physicist and mathematician Sir Isaac Newton is regarded by many as one of the most influential figures in the scientific revolution of the 17th century. Newton was born the 4th of January 1643 in Woolsthorpe, Lincolnshire, England. He endured a troubled upbringing as his father had died before his birth and his mother neglected him throughout most of his childhood. He attended King's School in Grantham, followed by Trinity College in Cambridge. By 1669, Newton had become the Lucasian Professor of Mathematics at Cambridge, and then in 1689 was a representative of Cambridge in Parliament. By 1696, he was appointed Warden of the Mint and soon after Master of the Mint. In the years after 1703, he held the position of the President of the Royal Science Society, and by 1705 he had been knighted, until his death on March 31st, 1727. Whilst Newton is most renowned for his scientific contributions, he is no short of having a definite impact on the area of mathematics as well. His biggest achievement is arguably his work in pioneering calculus, which proved essential for his ventures into the laws of motion. He conceived his method of fluxions, which was his name for calculating the slope of a curve. It involved the fluxion, which represented the rate of change in a curve, and the fluence, which were representative of a continually changing quantity, be it velocity, time, etc. As a result, he also discovered integration, which he found to be the method of finding the area under a curve. Furthermore, he soon established that integration and differentiation were inverse functions of each other. Newton was also partially responsible for what we know today as Newton's method, though his original method was only applicable to polynomials. Amongst these achievements, he was also a proponent of fractional indices and generalized binomial theorem. Newton's work can be seen as an extension upon Descartes' analytic geometry, as with calculus you can determine the area of shapes which are not enclosed by straight lines or parts of circles. Newton was said to have done his work on calculus during the years which the university had been closed due to the Great Plague of London during 1665–67. However, due to fears of criticism, he didn't publish his ideas until much later on in 1693, preferring at the time to circulate his ideas amongst a close group of friends. Gottfried Wilhelm Leibniz, a German polymath, however, had published work describing calculus himself several years earlier in 1684. Thus, a debate between who should be credited for the discovery of calculus ensued, eventually resulting in Newton being credited with its discovery and Leibniz with its first publication. However, debate and controversy still remained between the two mathematicians until Leibniz's death in 1716. Despite the victory over Leibniz in the debate, Newton's notation did not end up being used for differentials and integration, but rather it was Leibniz's notation of the extended S for integration and dy dx that are used to denote the respective concepts in calculus. In modern context, Newton's research and endeavours has had a profound and monumental effect on mathematics as we know it today. His method of fluxions paved the way towards a modern calculus. It also served as a cornerstone in the study of physics, as it is used to derive many physical equations and relationships, such as the relation of acceleration and velocity. As a result, Newton's insight can be drawn to be nothing short of astounding when taking into consideration the developments he made during his lifetime.